Hello and a warm welcome to the next project. In this project work, we will be tackling the simulation of a multi-species flow, and we will see how we can post-process the results along with the setup of the physics. I have in front of you a three-dimensional model. This model is resembling a box, but this is not a box. I'm assuming that this is a room, okay? And let us say this is a garage. And we have a car parked inside the garage. You can see over here. So this is a car which is being parked. Now I have really simplified the model of the car. So this is a kind of boxy shape, but in realistic your car will be more aerodynamic, right? So for simulation purpose, we can just simplify the models depending on our needs. And imagine the car is parked in this garage. The garage is ventilated with air, and you can imagine that the front face of this garage is completely open. Okay, imagine the complete shutter is open for the garage and the air is naturally vented. And what is happening is the bonnet of the car, from the bonnet of the car, we have certain amount of fire being created. Okay, so all this explanation what I'm doing is a sample simulation case what we are planning to do and tackle and involve the multi-species component in the simulation, right? So we are just building up a sample case to see how we can simulate that particular case. So this car is parked in the garage, and the car is the fire is generating from the bonnet, and the oncoming air into the room is from this side at certain velocity, say for example 0.3 velocity, 0.3 meters per second or 0.4 meters per second. And we have a kind of ventilation on the top which will allow the air to exhaust from there. Okay, so the air is entering from here and exiting from the background, and there is a fire generating over here, right? So this is what is happening in this garage, or in this room, you can say in simple terms. So in this project we will be analyzing the release of heat and combustion gases from this car bonnet, or the car you can say. And the parking garage or the garage is naturally ventilated. I mean, you're having the air entering from this side, clear? And we will be running a simulation by setting up all the physics based on the case what we have discussed so far, and we will be performing the simulation and see what is the outcome, right? Now we will be basically discussing the gases which are being emitted from this particular combustion process. Okay, so we are not bothered about the reaction of the gases, but we will be seeing the heat or the gases which are being generated from the fire are dispersing in which fashion, and what is the different post-processing aspects we will be covering in the post-processing section, right? Now first thing is, I have created a 3D model for this. Instead of creating the model in the ANSYS workbench, design modeler or space claim, I preferred rather to use a simple CAD software like Parametric. Clear? So this is the solid model what I've created. You can say this is a solid model, because if I'm just creating a cut section of this one, let me go to sections, and you can see it is a complete filled material, right? So this is a solid material what I've created a car with the solid material. Now I'm just creating a thin surface or a rectangle which is kind of what do you call, having no thickness. Okay, so I'll just turn on this sectional view and edit this sectional view. You can see the edges or the boundaries of the wall, those are thin surfaces. Okay, so that is basically replicating the ceiling, the floor, and the walls, the surrounding walls, right? So in this way we have to create the domain, and this is the complete domain what we have. Clear? Now coming to the dimensions, obviously I have scaled the dimensions to a very smaller extent, because in order to create a 7 meter or 5 meter room, 5 by 5 meter or 7 by 7 meter, or a realistic larger room, it will require me to have a licensed software for creating enough elements in the domain and performing the simulation. So For academic license, we will not be having the possibility to work in that extent. So in this, for that reason, I'm just simplifying. And moreover, because high sizes or larger domains require a lot of simulation time as well. And as we are a beginner and we are learning how to solve the multi-species cases, so we can consider a scaled model for our understanding. Okay, so the physics what you're setting up in a scaled model will be exactly similar to the physics what you have to set in case if you're working with the realistic dimensions, right? So dimensions are not important at this stage, especially if we are in learning stage, right? So I'm referring you in the v what I'm talking. Okay, so for that purpose I've just scaled the model, and we will just extend, I mean we'll just prolong, or we'll just move on with this particular model itself, right? Now as I've mentioned previously, we have to save this model, and let me just turn off the sectional view, and I'll just show you the model in no hidden form. So there is a car parked inside, and this is the outer walls. You can imagine the ceiling and the floor. So we have to save this model at some respected location in the step format. So we can see we have this step format over here, and after that we have to import the model in the ANSYS workbench. Clear? So I will be doing that, and in the next video we will be importing this particular file. So let us move on to the next video.